Okay, this is Mr. Hennon with another Hints to Help video. This one we're in the middle of simple harmonic motion. So we're dealing with a pendulum here. So let's see, let's get red here. A seconds pendulum. So that means its half period is 1 second. So that means actually t is 2 seconds. Okay? And then if we keep the idea that the period is equal to 2 pi times the square root of L over G, for part A, they want you to find the length if the acceleration of gravity is our normal 9.8. Now I put it on here that I wanted the answer to 5 significant figures because you're going to find very little variation when you're doing these parts. So the idea, if I were to take this lovely equation and try to solve it for L, I would be dividing by 2 pi. So we get that over to the other side. I would square it to get rid of this and then multiply by G. So I'd end up with L would equal G times t squared over 4 pi squared. Something like that. So if that's the way we're going to solve for L, then we can put in our G and we've got it. Second part, part B. And actually part C is going to be kind of similar, so I'll just kind of explain both of them at the same time. Now I'm saying, okay, it's the same pendulum, so that means the same length, but now gravity is different. How much time does it take? So what is the period? So part A, we're going to find the period. So we're going to go back to the original equation. We're going to say, okay, period is going to be 2 pi times the square root of L over G, but you're going to use the L you found in part A. So part A, and the G that you've got in part B, or C, okay? And then just solve for new t. Now obviously if gravity gets smaller according to this equation, then the time should get longer. It should take more time to swing back and forth, and if gravity gets larger, then the time should get shorter. So you should actually see that period change. The second part is the weird part. So how much time does it lose or gain every 30 seconds? So for this, it's kind of a little bit of a two-parter. So to find this time, what we're going to actually do is we're going to take half of the difference in your periods. So you're going to take the period in part A, which is going to be 2 seconds, and subtract the period you just found. So you're going to have the difference, so the period for part A and the period for part B, and then divided by 2. So that's the first part. So that'll find how much time, actually the difference in time. You should get like 0.001 or something like that. It's really, really small. And then when you do it in part C, same idea. The difference here is technically I don't want a negative, so you can get rid of positive or negative on there. I'm not worried about it. And I don't really need to worry about, you don't have to say whether you lose or gain. I put it on the document, but it's not a big deal. The first key I put, I think sometimes I forget to divide by 2 and I have it twice as big, and so I'm kind of accepting both answers because I was realizing periods kind of threw things off. But then you're going to multiply this by the number of seconds in 30 days. So if we've got 30 days, we're going to convert that into seconds. So we know that there are 24 hours in one day. And then we multiply, and if you look at the sheet, you'll see that there are 86,400 seconds in 1 hour. So, there are 86,400 seconds in one day, or you can use the fact that there are 3,600 seconds in 1 hour. So you can kind of combine these together, take the 24 times the 3,600, or split it up. You could even keep going if you wanted to instead do there are 60 minutes in an hour and 60 seconds in a minute, however you kind of makes sense. So when you multiply these 3 things together and multiply by that delta t, that's how you're going to find it. So I hope that helps.